And we're looking now at section 1.10, which is called, I know what I would call, okay, that's good. Systems of equations. And I'm going to start with a very easy equation, pair of equations. A system of equations means you're solving a bunch of equations together. For example, let me take a very, very simple example. And the question would be, find the values of X and Y. Now, the goal behind solving, this is called a system of equations, a very basic subsystem of equations. And what you're going to do is to try to get this systems of equations to drop one of the variables so that you only have one of the variables. And as you can see, if you take these two equations and add them together, x plus x is 2x, positive y and negative y becomes 0, is equal to 18. And then, of course, everything goes very smoothly from that point on. X is equal to 9. But we just don't want X. We also want to know what Y is. So you take one of the two equations, substitute the 9 into this equation, and you get the value of Y. And therefore, the answer to the question would be the point 9, 3. This is the answer to the question. So keep in mind that this is the easiest kind of equation that we will have, but the goal of solving this kind of problem will always be to find the positive, to get the positive and negative so that we're able to cancel it out. That's going to be the goal. So the next problem. So if you look at this, well, you know something? Play with it for a few minutes. Look at it for a few minutes. See if you can come up with something.
This is Rose.
Yes, go ahead.
Can you substitute for X 5 times 2 and 2 times 5? Or
I'm not sure I understand what you mean.
like, so since we need a positive and a negative, can't we just do substituting X for a positive and a negative number, making them like -10 and +10?
Well, it would be nice if this were a positive. Is that what you're saying? That this were a positive?
Well, yeah, but like times the 2 by -5 and times the 5 by a +2.
Oh, you want to get rid of the X's. Is that what you're saying?
That's what I thought of first.
Okay, that's fine. So you want to take this whole equation, right? And do what with it?
Times it by -5.
And what else would you like to do?
Times the 5 by +2.
Okay, let's see what happens. So let's do the first one by -5. So -5 times 2x is -10x. -5 times -10 is positive 50. And negative 5 times 2 is negative 10. Incidentally, it's necessary that when you're multiplying an equation by a number, that everything gets multiplied. It's not just what we want, it's everything in the equation. Here, we get positive 10x. Now this becomes negative, what, 40? Negative 40y equals 20. Check my work. I mean, that's what I'm doing now. Negative 10. And all of you should, always check my work, because as you know, I'm prone to mistakes. So I always try to check as much as okay. Now, what Rose did was, instead of in the previous problem, when I got rid of the y's, she chose to get rid of the x's. That's permissible. You could either get rid of the x's or you could get rid of the y's. It doesn't matter. So she chose to get rid of the x's. And did she succeed? Yes, because a negative 10 and a positive 10 becomes 0. Positive 50y and negative 40y becomes 10y equals 10. Negative 10 and positive 20. And then divide by 10, and y is equal to 1. Good. And now you have to go back to one of the two equations. Does it matter which one we go back to? No, it doesn't matter. So I'm just taking the first one, 2x minus 10y equals 2. 2x minus 10 times 1 equals 2. 2x minus 10 equals 2. Positive 10, positive 10. 2x equals 12. Divide by 2, and x is equal to 6. And the answer, as far as we know, is 6-1. But in order to really check it, if you wanted to check it, you could substitute in the second equation. 5 times, in other words, 5 times 6 minus 20 times 1 should equal 10. And you could see that 5 times 6 is 30, minus 20 does equal 10. There's your check. That's a complete problem from beginning to end. Good. Very good, Rose. I was thinking that somebody is going to say, well, somebody could construe this as easier if you simply multiplied the top by -2. Not even multiply the bottom. Because if you multiply the top by -2, then this will become a positive 20. And then you just drop out the y's and worry about the x's. But that's fine. That's good. Oh, but the important thing is that you multiply by something, numerator and denominator, if you must, to get rid of one of the variables. And you did that beautifully here. And then we were able to solve the problem. Good job. Okay. Any questions? Okay, here's another one for you to try. Let's begin, mainly because we're running out of time. And I have one last thing I would like to focus on with you. So again, you could get rid of the x's by doing the same thing Rose did down here, which was to multiply this by -3 and this by +4. But you could simply, but if you don't want to deal with negatives, you could multiply the top equation by 4, excuse me, the top equation by 7, and the bottom equation by 3. In other words, what are we looking for? Whenever we try to find something which cancels out, we're looking for the least common multiple. What is the least common multiple of 4 and 3? 12. So therefore, this gets multiplied by 3, that by 4. The least common multiple here is 21. So we could multiply, and I would like to do it that way, actually. So I'm going to multiply the top equation by 7, the bottom equation by 3. In other words, I took the 7 from here, I put it up here, I took the 3 from here, and I put it down there. And you wind up with 28x plus 21y is equal to 77. And in the second equation, 9x minus 21y equals -3. And what this does is when you add the two equations, the 21s drop out, and you wind up with 37x is equal to 74. And when you divide by 37, x would be equal to 2. Again, what I said was, if you didn't want to do the middle terms, and I like doing the middle terms because I didn't have to multiply by a negative, but if you want to get rid of the x's, then it's not good enough to simply multiply by 3 and 4. One of these would have to have been negative. But now we need to find out what y is equal to. So let's take the top equation, 4 times 2 plus 3 times, 3 times y equals 11. 8 plus 3y equals 11. It's always nice when you're doing a problem and the answer comes out to a whole number, especially in this type of problem. If you wind up with a fraction here, you're doing something wrong. The answer is 2-1. That's it. Again, I don't have time to do it, but you could have solved the problem by multiplying. Let me get this down so you can see at least what I've written here. That's what that looks like. You could have multiplied the original equation by the 3 and the 4, or 1 negative, to do that, but that wasn't necessary. I have one more problem to show you. Okay, so let me, we don't have much time. So let's, here's problem number 4 down here. So I'm going to move the board down. And this is what we have. 7x minus y equals 24. And then x is equal to 2y minus plus 9. I'm not going to even ask you to try this because we just don't have enough time. But these are the two equations. I will allow you enough time though to copy it. That's what you should do. Now you might say, okay, let's try to get this to look like the other 3 equations looked like, with the x and the y on one side and the number on the other. But if you get something like this, you could use a different method of solving. Since x is equal to 2y plus 9, you could take the x away from here and substitute 2y plus 9 minus y equals 24. This method of solving is called substitution. What you're doing is you're substituting for one of the variables. In this case, it's so easy to just take the x away and substitute the y, and you don't have to worry about what we were doing earlier. This is called substitution. That first method we were using was called elimination of a variable. But this may come up, and this is a very nice way of doing it. You get 14y plus 63 minus y equals 24. 13y plus 63 equals 24 minus 63 minus 63. The number we get over here better be a multiple of 13. That's what I'm thinking. So 63 minus 24 is 39. Perfect, right? But there's a negative here, and the 63, therefore, the negative sign will prevail. And when we divide by 13, y is equal to -3. And the answer is, oh, we didn't do x yet. So now you got to go up here to x. And x will equal to 2y plus 9. So x will equal 2 times -3 plus 9. X equals -6 plus 9, or x is equal to 3. So the answer is, I hope x is 3, y is -3. And it is. I just checked it in the first equation, and it came out 24 equals 24. So you may get a problem like that sometime in your future, where it's in this form instead of in this form up here, let's say. Okay, so that's a possibility also. And with that, the class is now over.